Hey guys, welcome to the next video on Python thread tutorial for beginners. In this video, we will see how thread synchronization works in the case of multi-threading in Python. And we will talk about how to use locks in the case of thread synchronization. So first of all, what is thread synchronization? So thread synchronization is defined as the mechanism which ensures that whenever two or more threads are executed in parallel or concurrently, and if they are sharing the same resource, in that case all the thread should not work simultaneously or parallelly on the same resource. So let me explain the thread synchronization problem with the diagram. So in this diagram, you can see there are three threads and all these threads are sharing the same resource. It can be a global variable, for example. So as long as all these threads are accessing this shared resource one by one, not at the same time, everything will work fine. But the problem arises when two or more threads try to access the same global variable or shared resource at a particular time. And this kind of situation is called the race condition. So a race condition occurs when two or more threads can access the same shared data and they try to change the value of this same shared data at the same time. And whenever this kind of race condition occurs, the value of the variables may be unpredictable, because if two threads are working on the same global variable at the same time, you will never know which thread has worked on this variable. So the result is the unpredictable value of a variable. Now let me explain this problem with an example. So I have this sample code in which in the first line I'm importing threading module, and in the second line I'm just declaring a global variable. Now I have two functions here. One is thread task and other is main task. Now inside this thread task function, I want to increment the value of x every time by 1. So this is the code for this, and I want to increment this value by 1 10 times. So that's why I have used this for loop in the range 0 to 9. So it's going to increment the value of x 10 times inside this loop. Now because this x is a global variable, I have just added this global keyword in front of x. So our function knows that this x is not a local variable, it's a global variable. So this function is simple enough. It just increments the value of x 10 times inside the loop, and this x is this global variable which we have declared outside this function. Now in the main task, what I'm doing is I'm creating two instances using the threading module with the help of thread class. This we have already seen in the last video, how to create threads using threading module. So nothing new in this. I have created two instances, T1 and T2, and I'm passing the target is equal to the function name, which is this function, which is thread task. So both the threads will call the same function, thread task, and then I'm just starting both the threads with the help of start function, and then I'm just using the join methods on both of the instances. Now here inside our main if condition, I'm just calling our main task in which our threads are created and executed, and then at last I want to print the value of x when all the thread execution has been completed. So let's run this script and let's see what happens. So you can see here the result here is 20, which is expected because we are incrementing the value of x 10 times using two threads. So the value of x will be incremented 10 times by thread T1 and 10 times by thread T2, and as a result the value of x becomes 20. But as soon as I increment the value of this range, let's say this is 10,000 and I want to just execute this program once again, there is no problem until now. We can just run this program again and again. We will not see this problem because we are incrementing the value of x 10,000 times with a single thread. So we have two threads and the result is 20,000, which is absolutely fine. Now let's increment the value of range once again to 100,000, and now I want to show you the problem. So as soon as you do this, you can see that the thread synchronization problem occurs. So here you can see the result is not 200,000, which we were expecting, because for such large value, this scenario of thread synchronization is happening. So the two threads try to work on the same variable at the same time, and as a result, the value of x is unpredictable. So this thread synchronization problem you will see when you try to work on a same variable multiple number of times. So in this case, we have 100,000 iterations and both the threads try to iterate over the same variable using two threads, and the result is unpredictable. Let's try to execute this once again. So you can see the result is always different every time I execute this program because the result is unpredictable. So how to solve this problem? So one way of solving this problem is by using the locks. So first of all, let me just change this program and try to use locks in this Python script. So to use locks, what you can do is you can declare a local variable here. For example, lock is equal to threading dot a class called lock. So this is going to give you an instance of lock. Now this lock class have two methods. One is acquire and other is release. Now acquire method is used to lock and release method is used to release the lock. So let me just complete this script and then I will explain what does these functions do. So what I'm going to do is I'm going to pass this lock instance as an argument of the thread task function. So I'm going to just write args is equal to, and then we will just pass our lock instance as an argument of this thread task. Same we will do for the second thread. And because we have passed this argument, we need to add this argument here also. So I'm going to just pass the lock instance as an argument of this function. And now at last, what we are going to do is just before we change the value of the global or the shared data, we use this lock variable and call the method called acquires. And just after you finished changing the resource or the shared data, you use a method called lock.release. So once again, we have passed this lock instance which we got from this lock class as an argument of this function. So this is the lock instance, and there are two main methods inside this lock class which are acquire and release. This acquire method you use to acquire the lock. This lock can be blocking or non-blocking. So this acquire method takes one argument which is true or false. By default, the value of argument is true, which means that this acquire is blocking by default. So what does this lock.acquire will do? It locks the access of the shared variable. In our case, this is x, and at this time only one thread can work on this variable, whatever thread have the access to this function at a particular time. So until and unless one thread execution is completed on this variable, after that this lock is released. That means that the other thread can work on this variable using the lock once again. So whenever second thread wants to try to access this variable, it will just lock the access to this variable first of all, and then work on this variable, whatever you want to do. You want to increment the value or change the value of x, and then release the lock. And releasing means that we once again want to allow the other thread to work on this shared resource. So this mechanism will allow only one thread to access this shared resource at a particular time, so the thread synchronization problem will not occur. So now let's just run the program once again and let's see what's the result. So you can see this problem, and this problem is coming most likely because of this problem, because we haven't provided args as the tuple. So we need to provide this arg as a tuple. So always remember, whenever you want to pass any argument using this args keyword, you need to pass them as tuple. So once again, I'm going to just try to run this program, and you can see the result is whatever we expected. So because we are incrementing the value of x 100,000 times, and there are two threads which are working on the same variable, so we get the 200,000 result which is expected. Now let me run this program again and again, and you can see every time now we get the expected result, which is 200,000. So this is how you can solve the thread synchronization problem using locks. So this is how you can use locks to synchronize your threads in Python. I hope you have enjoyed this video, and I will see you in the next video.